Welcome to our talk on human-centric preference modeling for virtual agents. This is actually a 4-page position paper, so I actually doubt that I will need the full 15 minutes, but here we go. So yeah, my name is Bart Knijnenburg. I'm a professor in human-centered computing at Clemson University, and I co-authored this paper with Nina Hubig, who is a professor in computer science in the same university. So Nina is an expert in machine learning, and I'm an expert in human decision making. And this is actually our first paper at the IVA conference. And today we are going to talk about advice-giving agents. The algorithms that tend to underlie such advice-giving agents usually come from fields like user modeling and recommender systems. And those are fields that Nina and I are intimately familiar with. So that's why we decided to write this paper for IVA. So the argument that we make in the paper and that we're going to present today is that these algorithms tend to be optimized for making predictions and not for giving advice. And that's a problem when we want to create advice-giving agents. So that's the argument we're going to make. And so to make this argument, we must first outline some of the qualities of good advice givers, right? So a good advice giver is someone who truly understands you, someone who can see your potential, and someone who listens to your feedback so you can stay in control, right? So in this talk, we will explain how the current prediction algorithms that are used by advice-giving agents kind of fall short of these goals, and how we can build advice-giving agents that actually attain these goals. All right, so let's start with what is probably the most important thing in a relationship, right? Is someone who understands you. So do the prediction algorithms in current advice-giving agents actually understand you? Well, these algorithms, they make predictions based on users' inputs, right? And these inputs are usually kind of limited because our day-to-day behaviors tend to reflect our short-term interests more than our longer-term goals. And it's also the case that these prediction algorithms, especially the ones that are used in commercial systems, are often purposely built as kind of traps that reinforce these short-term behaviors. And so this in turn kind of limits the advice that these systems can give us. All right, so how do we build agents that actually truly understand their users? Well, we can do that by explicitly modeling aspects of the user state of mind using multiple sources of data. And luckily, when we have conversations with agents, there's usually, this is usually a much richer type of interaction than our interaction with point-and-click interfaces. So, so we can actually leverage the dialogue that we have with these agents, like the conversational progression and the sentence structure, as well as the user's voice and gaze and facial expression and emotion. And so we can use this for uncovering users' preferences. Now, these things have actually already been used in agent-based systems. I've seen several papers at the IVA conference before, but our idea is not to just use them to optimize the conversation, but to actually use them to uncover users' preferences. So what about reaching your full potential, right? Do these prediction algorithms actually try to see your full potential? Well, the objective function of a prediction algorithm is typically to just model the available data, right? And because of this, they're very good at modeling the current state, so things that currently are happening, rather than possible future states, what can be. And so because of that, they often forego our long-term goals and needs. And that's quite unfortunate because the decisions that we tend to need help with are seldom the ones that are about the present and more the ones that are about our future. So how can we build agents that help us realize our full potential? Well, we can do that by bending the algorithms to take a more forward-looking perspective. Now, one way to do this is by recommending items that are not universally liked by similar people, like what typical algorithms do, but that actually are by recommending items that are controversial among these nearest neighbors, thereby pushing the user to explore their preferences beyond the mainstream. Another is to allow the user to break free of their own user models, such as by merging their profile with those of aspirational peers. So for instance, I could merge my fashion preferences with those of a cool friend and then get recommendations based on our combined profile. Or we could allow the user to imagine a desired future state, like a job that we would like to have, and then give recommendations based on the past actions of people who have already attained this desired state in the past. Now, what about control? Do the prediction algorithms in current advice-giving agent actually listen to your guidance and your feedback? Well, most prediction algorithms are built as black-boxed closed-loop systems, and the only way to really adjust their output is by actively changing your behavior. But because these systems are persuasive and they tend to automate the consumption process, they kind of create a feedback loop that replaces rather than supports the user's decision-making practices. And these problems are actually exacerbated with virtual agents because they are typically anthropomorphized, which means that they're more persuasive. And they're also interfaceless, which means that they rely more on automation. So that feedback loop actually becomes stronger and stronger. So how can we build agents that actually listen to their users' feedback? We can do that by building dialectics into the user-agent dialogue. So this means that we sometimes need to explain the recommendations and actually give the user the opportunity to critique these recommendations. And it also means that at times we should answer the user's question with another question rather than with a recommendation. And this allows the agents to engage in kind of iterative refinement of the user's preferences, which we have to realize may not always be very well established to begin with anyway. So helping the user understand their own preferences is actually a very important component that we can build into these systems. So let's recap these principles and then propose a somewhat more comprehensive way forward. So to sum up, advice-giving agents should explicitly model aspects of the user state of mind using multiple sources of data, bend their algorithm to take a more forward-looking perspective, and have dialectics built right into the user-agent dialogue, right? So one way to do this comprehensively is what we will call a human digital twin. A digital twin can act as a mirror for your preferences. So just like how writing things down can help you reflect upon your thought processes, a digital twin can help you reflect upon your preferences. Now, this practice of iterative refinement and reflection creates a human-agent partnership that doesn't replace, but rather supports the user in their discovery and refinement of their tastes and preferences. And our vision is that in the long run, such agents can come to embody who you are as a person and thereby gradually move away from the interactive elicitation of your explicit preferences to more abstract discussions of your higher level values. So that's all from us, and thank you for listening. We're happy to answer any questions.